Hello, this is Gallagher Fluid Seals. Today, we are going to discuss DuPont Kalrez compression set resistance and sealing force retention. Then, we'll look at some of these characteristics in comparison to Viton. Stretch and compress, two important factors in sealing ability. Since most Kalrez parts are used as sealing elements, the retention of adequate sealing force over a long service life is an important property. One method used to evaluate sealing force is compression set resistance, or to put it simply, a measure of resilience or recovery of an elastomer. It is a useful preliminary quality control test, but not necessarily a good indicator of service life, since it does not reflect three areas of concern: long-term use, actual application temperatures, or the effects of aging. When measuring compression set resistance, the sample to be tested is compressed by 25% of its original height between two metal plates. The fixture can then be put in an air oven or any other chemical media for a set amount of time. Normally, the standard test is 70 hours. After release from the clamp at room temperature, the height of the sample is again measured after 30 minutes. The percentage of compression that is not recovered is expressed as its compression set. Once the sample is released from the test fixture, it will return to a certain percentage of its original height. For example, a sample that has recovered 80% of its compression is considered to have taken 20% compression set. Kalrez compounds have higher initial compression set than Viton at lower temperatures. Kalrez Spectrum 7075 provides good compression set resistance up to its upper service temperature limit of 572 degrees Fahrenheit, while Kalrez 4079 maintains low compression set resistance up to 600 degrees Fahrenheit. In contrast, Viton's compression set is very good up to 400 degrees Fahrenheit, at which point it quickly climbs to an unacceptable 100% and no longer provides sealing force. Good resiliency, expressed as a low compression set value, is also very obvious when temperature cycling takes place. Kalrez 4079 exhibits superior thermal cycling performance, even better than Kalrez Spectrum 7075. Therefore, it has been widely used in the aircraft and aerospace industries, as well as many chemical processing and related applications where thermal cycling takes place. The sealing force or stress relaxation test is a much better test than compression set resistance for estimating long-term service performance. It measures the force exerted by the elastomer on two plates. The drop in force can be plotted against time to give an accurate measure of a material's actual sealing ability. When the stress relaxation test fixture is used, a test specimen is placed into the fixture and compressed to 15% or 25%. To measure the retained sealing force, the fixture with the top force plates secured is then put into an Instron tensile tester. The force, F, on the top anvil is equal to the force in pounds exerted by the sample. At this point, force F will be equal to 100% of the sealing force of the O-ring control at a specified compression, either 15% or 25%. Then the fixture is put in an oven for hot air testing, or it can be immersed in fluids at temperature to get an accurate idea of the elastomer's performance versus time. This shows the decline of sealing force of various common seal elastomers exposed to air at 300 degrees Fahrenheit. Silicone and fluorosilicone elastomers seal adequately at 300 degrees Fahrenheit before reaching a potential leakage failure at around 10,000 hours. This test provides a relative comparison only, since actual sealing performance is dependent on many other factors, and service life may be less than indicated in this test. Even so, as you can see in this graph, after 10 days of testing, the Viton sample loses considerable sealing force and crosses below Kalrez compound force plots. At the 200-day test mark, the fluoroelastomer has lost all sealing force. Kalrez 4079 exhibits excellent retained sealing force beyond the actual test. Extrapolation of the plot indicates service life of over 10,000 days. With increasing temperatures, the sealing force retention of conventional elastomers deteriorates quickly, as illustrated in this comparison of performance of Kalrez 4079 and a Viton compound. At 450 degrees Fahrenheit air, the fluoroelastomer, a Viton A-type, rapidly loses sealing force, and at 20 to 30 days it has reached zero force and has embrittled. In comparison, Kalrez 4079 has the capability of maintaining sealing force for over 10,000 days. Hot air aging is one of the most stringent tests. In other chemical environments, Kalrez 4079 has retained good sealing force properties at temperatures up to 600 degrees Fahrenheit. Before we sign off, and as a reminder, highly toxic products can be generated when FFKM parts are exposed to fire or temperatures in excess of 750 degrees Fahrenheit. So, respiratory equipment should be used if ventilation is inadequate. Also, FFKM should not be exposed to alkali metals or interhalogen compounds, as they are incompatible with both. We hope this video has given you a better understanding of the different properties to consider and compare when choosing a rubber compound, as well as the differences between Kalrez and Viton. Hopefully, you've gained a better understanding as to how sealing force retention is the true measure of any elastomer. For more information about FFKM or Kalrez, visit our website at www.gallagherseals.com. Thank you.